Exactly. So you go about and graph this. You end up with an enclosed region. What's the vertex of the first parabola? What's the vertex of the first parabola? Where does, yeah, 2, 0, correct. Nice. It goes there, there, up 4, crosses there, goes over right there. Excellent. So our first function is right there. How do you go about graphing this one? What's a good thing to do? You could do the y-intercept. You know it's going to cross at what?
0, 7.
You know it's going to cross at 0, 7. That's correct. So we cross at 4. So you know that this thing is going to cross at 3, 4, 5, 6, 7 right here. Is that correct?
Yes.
Oh, and I graphed this entirely. I totally graphed this one wrong. Why are you letting me graph it terribly like that? The vertex is there, but does this thing cross at... Where does this thing cross the y-axis? It crosses at 16. Let's still call this 16 and use a different scale. Okay, so this is 2, that's 16. Is that okay? Just make it so you can actually draw a nicer picture, which I'm okay with. Okay, so we do this, that away. So what do we end up with? We end up with a badly drawn parabola, but I'm doing my best here. Okay, there we go. So then we have, for this one, it crosses at 7. So, you know, it's going to cross, I don't know, right about here. And what's the x-coordinate? Oh, that's a great thing. X-coordinate of the vertex we could find, right? Negative b over 2a. So that's going to be negative 4 over 2 times 1. So that's going to be at 2. And in this case, when you plug in 2, what's y of 2 going to equal? 4 minus 8 plus 7. What's that equal to?
3.
3. It's equal to 3. So what does this thing look like? We end up with a parabola like this. So what's our enclosed region? Our enclosed region is right there. There's our enclosed region right there. So what's the next thing we should find for our enclosed region? Just hint. What should we do next? Points of intersection, exactly. So you want 4 times x minus 2 squared is equal to x squared minus 4x plus 7. So you have 4 times x squared minus 4x plus 4 equals x squared minus 4x plus 7. So you end up with what? 3x squared. 16 was it minus 12x. 16 was plus 9 equals 0. What do you factor out first? 3 times x squared minus 12x plus 3. I know, I see, I know it's a 4. Yep. Plus 3 equals 0, so it's going to be 3 times x minus 1 times x minus 3. So what's x equal? 1 or 3. So our integral is going to go from 1 to 3, correct? We know that so far. Now, what's the next thing you should draw after you draw that first one, if you haven't done this a bunch of times yet? Draw the reflection, right? So if you draw the reflection of this thing, you end up with something that kind of looks like that. And then what should you draw after you draw the reflection? One of your shells, right? So there's one of them, there's the other, like this. So there is your shell right there. There's your shell. So we're going from, what do we park on the outside of this thing?
Or 2 pi.
2 pi, correct? And then it's the radius times the height. And is it dx or dy here? Dx, that's correct. In this case, what's the radius going to be? X. It is x, yeah, right, because it's going around the y-axis. So it's 2 pi from 1 to 3 of x. And what's the height going to be? Upper function minus the lower, right? The upper one is the red one, so it's going to be x squared minus 4x plus 7 minus 4 times x minus 2 squared. There it is. Now, how do you go about integrating that?
You just
do it out, exactly. You just add from the blue, it's going to be negative, what is it, negative 2x plus 6. And what are you subtracting from it? What are you subtracting from it? We're taking this, and what are we subtracting from it?
Negative y over 2.
Nope. Negative. You have to put that negative in there. That's why I drilled it at the beginning. So it's minus the negative root y over 2. Yeah, did I make a mistake? Let's go back and look at this. We're not going to. I'll get you the numeric answer in a second. But let me draw that shape again. Because what do you have for shape? You have a parabola like this. You have a parabola like this, and you are cutting it with there and with there. So what's another way you could draw the shapes that would make this easier to integrate? You could use washers. If you use washers on this, how many integrals do you need? you just need one integral because you can scan all the way from the left to the right. In this case, are you integrating with respect to x or y?
X.
X, and you're going from -3/2 all the way to 1, right? Remember, it's pi times the big R squared. What's the big R squared? Is this dx or dy? That's important. Dx, right? Our bigger radius is the blue one, right? So that was what? -2x plus 6 squared minus, what was the lower function? 4x squared squared. Is that a little bit easier to do out? Yeah, it is. Theoretically, should you come up with the same answer? Yeah. When you're given a choice, visualize the slice, visualize the shell, and pick one. Turning it into a function? No, we're just turning it into two functions, right? So what do you have here? X squared minus 7 is equal to y squared. So what does y equal? Plus or minus the square root of minus 7. Could you plug this into your calculator to graph it? Did anybody actually come up with a picture of this in some manner? Yeah, if you graph this, where does it cross the x-axis? At root 7, right? And at where else? Negative root 7, right? And if you graph this thing, it ends up looking like this. So this right here is root 7. Do you agree with that? What's our other boundary? X equals 4. What kind of line is that? What kind of line is x equals 4? Vertical line. Ready? Here's x equals 4. What's the enclosed region? Do you see it, everybody? Do you see the enclosed region right there? There's the enclosed region. And what are you rotating it around? Y equals 5. So y equals 5. So I need some more space, don't I? So y equals 5, let's say, is right here. It's that big. So after you draw this, what would be a great thing to draw? The reflection over y equals 5. Over y equals 5, exactly, right. So if we do our reflection properly, we have to be careful. It's going to be about the same distance. So 1, 2, 3, 4.5. So right about here. Who knows? Look like this. Look like this. And I kind of lined it up. That's okay. And then it cuts off again right there. So do you see theoretically what this is going to look like? I'm doing my best here. I'm doing my best. And it's going to be a little warped. So we have this slice and we have this slice. So what's this sucker going to look like? It'll look like this. So does everybody see what's happening in terms of rotation in the solid? Okay, are we integrating with respect to x or y? So we know it's dy. So if we're going to do that, we need to find our intersection points. And that's pretty easy to find because we know that what does x equal on those points? But we're interested in the y values, right? So we have 16 minus y squared is equal to 7. Can someone tell me what y is equal to? Not a trick question. Or plus or minus 3. So we know we're integrating from -3 to 3. Good. And it's 2 pi times the radius h. Are we okay with that? Okay, where's the radius come into play here? The radius is the distance from y equals 5 to y. What's the distance from y equals 5 to y? What do you do with those two things? You subtract them. This is the distance between 5 and y. We know y is less than 5, so we subtract it from 5. Are we okay with that? So that right there is our r value. How do we go about finding our h value? Where is our h? Our h is right here. That is our h value. Is it a horizontal distance or a vertical distance? It's a horizontal distance, so it's an x value, but it needs to be in terms of y. So we know that function was x squared minus y squared is equal to, so what does x equal? 7, yeah, plus or minus the square root of 7 minus plus y squared, exactly. Plus or minus 7 plus y squared. So half of them are positive, half of them are negative. We want the ones that are what? Because that's on the, see the yellow right there? All of the x values are positive. So we want the positive one. So if we want the h here, what is h going to equal? Close. It's on the left side. So what do we have to do first? We have to start with, this is the distance, right, between two things. To find the distance between two things, do you add them or subtract them? 4 minus the square root of 7 plus what? Y squared. So there's our h. So what is our integral going to look like? It's going to be the integral from -3 to of 5 minus y times what? H, which is this thing, right? Now they say set this up but don't solve it. Why do they say not to solve this one? You can't. You just flat don't know how to do that. Can someone tell me the one piece in there that makes it so you guys cannot integrate this? Nope, the root doesn't make it impossible. The root by itself does not make it impossible. You need to give me more than that. What specifically about the stuff under? Because you have integrated things with radicals and stuff under the radicals.
You can't use substitution.
U substitution will fail. Can someone tell me specifically why U substitution is going to fail? There's nothing to cancel. Right. If you have a y squared on the inside, what do you better have on the outside? And it better be multiplied by there. If you try substituting, you try u equals 7 plus y squared. You do the substitution. Does it work? No. Can you use your calculator to do this? Absolutely. Would you have to? Absolutely. Do I even remember how to do this one by hand? No. I absolutely don't. I don't remember how to do this one by hand. I have a couple ideas, but I can't do them in my head to tell you if they were correct.